welcome back to VSM Math tutorial. Dear students, in this class we are going to deal with one of the important concepts in operation research as well as management science. So that is sequencing models. So what exactly is sequencing problem? So what is the importance of sequencing problem? We'll deal one by one. So first important thing is, what is sequencing? What is sequencing problem? Sequencing problem. So answer is very simple. Okay, so in daily life also we use the word sequence, and especially those who are familiar with mathematics, they already know sequence. Sequence means, or sequencing problem means, it is the process of determination of an optimal sequence or optimal order for performing some set of jobs or series of jobs by a number of facilities. So that are used to optimize the total time or cost. Actually, this is very important concept when it comes to minimize the cost, maximize the profit, as well as minimize the total distance, minimization of total time, minimization of total cost. So all those are all part of the sequencing or applications of the sequencing problem. Okay, so what is sequencing? It is process of it is process of determination. It is process of determination of an optimal order, or sequence, an optimal order or sequence for for performing a series of jobs, a series of jobs by a number of facilities, series of jobs by a number of facilities to optimize the total time or cost. Optimize the total time or cost. Okay, this is the definition of sequencing problem. Very important. It is the process of determination of an optimal order or an optimal sequence by performing a series of jobs by a number of facilities to optimize the total time or cost. Okay. Now, what is the importance where it is used? Sequencing models. What are the applications? Okay, sequencing models are mainly used in networking areas. Remember, this is real life application I'm telling. So sequencing problems or sequencing models are very important in networking area or networking fields. For example, you take railway network. Okay, uh, you take airline network, or you can consider road network. Wherever this network concept comes, no, so their sequencing models are very important. Okay, so after finding the sequencing model, one of the important techniques or tool we are going to operate now, that is called Johnson's algorithm. Okay, so that is very important tool or technique. It is used to find out the proper sequence or proper order for jobs. Okay, so that is the next important concept, that is called Johnson's rule. Johnson's rule, or it is also called Johnson's algorithm. What it says: or what is the definition? So it is the, or it is a solving technique or solving tool, solving technique used to find, used to find the proper sequence, used to find the proper sequence, used to find the proper sequence or order of jobs. Okay, so Johnson rule, it is one of the important technique or solving technique which is used to find the proper sequence. Okay, so which is used to find the proper sequence or order of jobs. Remember, this is, it is solving technique, it is a solving technique or a solving method which is used to find proper sequence or order of jobs. Okay, this is Johnson's rule. Then we have some types of what we call it as just erase this data because I need to. There are some types of sequencing problems in the standard format. We'll go one by one. Okay, so what are the sequencing models? I'll just take sequencing problems with sequencing problems with n jobs, sequencing problem with n jobs, or problems with n jobs on two machines. This is first important type. Then problems with n jobs on three machines, n jobs on three machines. You can use word also with n jobs with three machines, n jobs with two machines. Next, problems with n jobs on m machines, m jobs on m machines. So you can also use the alternate word k. In most of the textbooks or most of the notes, they are used n jobs on k machines. And there is just letter here. Then the last one, problems with two jobs on m machines or k machines. Okay, so these are the types of sequencing problems. Okay, these are the types of sequencing problems. What are the types? Just follow with me. Problems with n jobs on two machines, problems with n jobs on three machines, problems with n jobs on m machine or k machine, and problem with two jobs on m machines. Okay, so these are the important types of sequencing models or sequencing problems. So now we'll go with one by one. The first important thing what we'll do, will solve n jobs on two machine problem. So the first type we'll consider this type, that is n jobs on two machines. Based on this, we'll solve some two problems. In the next video or next session, I'll consider some two problems on each concept. Okay, so let me take one simple problem on this problem with n jobs on two machine concept. So these are very important in management science as well as mathematics, especially in operation research. So Very simple concept. So I'll just use the Johnson algorithm because it is the better technique to get the optimal sequence. So I'll solve problem with Johnson algorithm only. I'll take one simple example or problem with Johnson algorithm. So the statement of the problem is using Johnson's algorithm, using Johnson's algorithm, find the using Johnson's algorithm, find the sequence that minimizes that minimizes the total elapsed time, total elapsed time required to complete the required to complete the total elapsed time required to complete the given jobs on two machines. Complete the given jobs on two machines. Also find the idle time for two machines. Also find the idle time for two machines. Okay, so they have given data. I'll just write that data also. Since it is a digital pad, I'm just drawing roughly. So these are the jobs we have, these are the machines we have. Let it be A and B, and what are the jobs we have, I'll write here. So A, B, C, D, E, these are the 5 jobs. Since I used this, I'll take it as M1 and M2, machine 1 and machine 2, because here also ABC I'm taking, so it may create the confusion. That's why this is ABC jobs and M1 and M2 machines. 4, 3, 5, 7, 8, 2, 9, 1, 3, 5. Okay, this is the problem. You can see using the Johnson's algorithm, find the optimal sequence or simply sequence that minimizes the total elapsed time required to complete the given jobs on two machines. Also find the idle time for two machines. Jobs are given. There are 5 jobs A, B, C, D, E, and there are two machines. We have M1 and M2. So the time is given. Usually it is in terms of hours. So we'll consider this as hours only. Okay. Now, how to find out the optimal sequence? There is a procedure. Now, first important thing, whenever we have problem on optimal sequence, so first thing we have to write the proper optimal sequence. How to do that? So we have to construct one table. Okay, I'll just write solution here onwards. Solution. So what I'll do, let us construct the table to get an optimal sequence. Table means the data only I'm writing. So with the table we can easily get the points how to find out the optimal sequence, I mean procedure, everything. There are 5 jobs we have. 2, 3, 4, 5. This is jobs and this is machine ABC. Machine 1, machine 2. Jobs machine 1, that is M1. Machine 2, that is M2. How many jobs we have? A, B, C, D, E. Now machine 1, machine 2 time also given, that is 4, 3, 5, 7, 8, then 2, 9, 1, 3, 5. See here, I just written the one table, simple table. This table helps us to find out the optimal sequence. So jobs are given, so jobs I have written, machine and their time is given, so machines and their time is we have written. Now we have to write the optimal sequence. So I'll just write optimal sequence for this. One, 2, 3, 4, 5. Okay. So you can see here in this table, in this particular one simple row with 5 columns, what it indicates, this indicates optimal sequence. So this direction, it is usually M1 machine direction. This machine direction, it is usually M2 direction. Now how to find out optimal sequence? What Johnson algorithm says. In the entire table, machine 1, machine 2 time, we have to find out the smallest time. We have to find out the smallest time. So out of this, which one is the smallest time? 1 is the smallest value. So this will be the smallest time. And the smallest time for what job? C. Okay. Since the smallest time for machine 2 and the job for machine 2 is C, so the first job for machine 2 is C. We can write here. We can write here. I hope you got it, how to find out the sequence. So in the table we have to find out the smallest value or smallest time for both the machines. Here 1 is the smallest time, that one smallest time for machine 2, and the allocated job for machine 2 is what? C. That is the reason I have written C. So once if we write C, we have to erase this particular row because no use for further computations. I'll just strike out this row. And next find out one more smallest value. After 1 we have 2. So we have 2. This is the second smallest value, and this 2 is also for what? Machine 2 only, and allocated job for machine 2 is A. Okay, so that is A will come here. Don't write here, don't write A here because this is for machine 1 jobs. Okay, so this 2 is allocated for machine 2, therefore we have to come with from this. So 2 allocated job is A, so A will come here. So once if we write A job, we have to erase this. Then we have to find out again smallest value. Again smallest value we can see here, 3 is there, 3 is there, but both in the opposite sides there is no tie. Say if both 3's will come in the same machine 2, then that is call it as tie. But here this is not tie, so it is clearly both are in opposite, different jobs. Okay, both times are different jobs, so it is not a tie or not a clash. So 3 for machine 2, 3 hours per machine 2 allotted job is D, so you have to write D, and Just I'll write D here. Now you can see here this 3 hours allotted for machine 1 for the job B. So job B is for machine 1. This is the first job for machine 1. We have tried B here. We have tried B here. Don't write here because if we write again M1 starting job, we don't know. That is the reason. So clearly from this data, allotted job for machine 1 for 3 hours is job B. So job B. So once we write job A, what is the left out? Left out one is A. If you check also, that is for machine 2 will come here. So that is A. So this is our optimal sequence using Johnson algorithm assumptions. Okay, Johnson algorithm assumptions. There are some assumptions for Johnson algorithm. So very simple assumptions. What is that assumptions? No machine can process more than one operation at a time. This is very important. Remember, no machine can process more than one operation, more than one job at a time. Second one, each operation gets started must be performed till the completion. Suppose if machines 2 started one particular job, it has to complete that particular job, then only it will move on to the next job. Okay, so these two are very important assumptions in Johnson algorithm. What are those? First one, no machine can process more than one operation time at a time. Each machine once gets started, it has to perform till its completion. Okay, so once we got this optimal sequence, then we have to find out the minimum elapsed time with the help of this optimal sequence. With the help of this optimal sequence. So I'll just write the optimal sequence this side. So another side I'll just write table. So optimal sequence is B, that is E, that is D, that is A, C. So this is our required optimal sequence. Required optimal sequence. So I'll just erase this part and I'll write the table, computation table. Johnson algorithm is very simple. So only thing we have to remember the steps and methods properly. Okay. So now once we got the proper optimal sequence, then we have to find out the minimum elapsed time. So for that we have to write one simple table. I'll just write that simple table. So please be careful while writing the data, because since it is completely deals with numerical value, knowingly or unknowingly if we write wrong data, so answer will be, final answer will be wrong. We may not get proper answers. Okay. So we have 5 jobs. We have to write jobs not in this order. We have to write jobs in the required optimal sequence order. This is our optimal sequence we got from the inspection or trial method, Johnson algorithm method. So we have to write this sequence, I mean in the standard form. So here I'll just write this is for B, this is for E, this is for D, this is for E. I mean C. So this is in time, out time, and idle time. In time, out time, idle time. Okay, so let me take this. These are the jobs. Machine 1, machine 2. So this is machine 1 in time, machine 1 out time or completion time. If there is an idle time for machine 1, that we have to mention. This is in time for machine 2 and out time for machine 2, and if any idle time for machine 2, that we have to write. So as I told, jobs we have to write in this order, optimal sequence order, not in the given order. So as per optimal sequence, the first job is what? B. Second job is what? E. Next job, I'll just write first job B, E, B, A, C. This sequence I have written. Now you look at the table, given table. This is B. Job B, machine 1 will take how much time? 3 hours time. So to complete this job, it takes 3 hours time. So therefore we cannot write in time as 3. The completion time is 3. So it will come out time. So here starting usually 0. So it is 0. Out time is what? 0 plus 3. Okay, started time and the allotted time. So since the machine is not waiting for any time, so idle time is what? 0. Now for machine B, job B, machine 2, how much it is? 9. So machine 2 will started working after machine 1 is completing its work. Means this 3 hours time should be completed, then only machine 2 will start working. So the in time for machine 2 will be that 3 hours. Okay, 3 hours. So out time will be what? So this 3 hours plus this job allocation time for machine 2, 9 hours. So how much it is? 12 hours. Is there any idle time for machine B or machine 2? Yes. Because till the machine 1 completes its job, machine 2 is simply nil. It is not working. So the machine 2 should wait 3 hours, because 3 hours is the completion time for machine 1. That is the reason this 3 hours machine 2 should be idle. That is the reason idle time for machine 2 is what? 3. Okay, job B is over. This job is over, finished. Then we'll move on to machine E, because in the optimal sequence we have job E. So for job E, machine 1 take how much time? 8 hours. So in time is not 8 hours. Here be careful, because once the job B is completed, then only it will move on to the job E. Therefore start time for job B is what? This start time for job E is what? This B out. So once the job B is completed, then E job will start. Therefore in time for job E is 3. So 3 plus what is the E job? 8. So that is 8. 3 plus 8 how much? 11. There is no idle time. Machine is not waiting anymore. Now you can see here machine 1 completion time for job E is 11 hours. Machine 2 already taking to complete the job is 12 hours. Means after completion of E job by machine 1, machine 2 is still working 1 hour. Okay, it is not idle, it is simply working. So there is no idle time for machine 2 for job E. So once it completes this job B at 12 hours, then only it will start job E work. Therefore this 12 is the in time for machine E. So how much for machine E, for job E, machine 2 time is given 5. So 12 plus 5, it is 70. Similarly, D, when it goes to job D, once the job E is completed, then only machine 1 will perform job D work. Therefore, in time for job D work is out time of job E, that is 11. So once job is completed, you scratch out. So it is 11 plus job for machine 1, how much time? 7. So it is 18. The machine 1 is not waited any time for job D, so nil. But you can see here, it is very important. For job D, machine 1 is taking 18 hours. But to complete job E, machine 2 is taking 17 hours. Till this job D should be completed by machine 1, it has to wait. But its closing time is 17, but its closing time is 18. So it has to start, machine 2 has to start after 18 only. But its closing time what? 17 hours. Means 1 hour it has to wait. 1 hour this machine 2 has to wait. That is the reason the idle time for machine 2 is what? 1 hour. So 18 plus how much it is? 3. 21. Once we written, scratch out. Now machine A in time is closing time of machine D, that is 18. Now 18 plus what is the time for machine 1 job A? 4. So 18 plus 4, 22. Again here also, to perform job A work, machine 2 has to wait 1 hour, because machine 1 will take 22 hours to complete it. So job D is completed by machine 2 at 20. Closing time is 21 hours for job D, but opening time for job A is 22. So machine 2 has to wait 1 hour again. 21, this is 22. So 22 plus what is the job A for machine 2? 2 hours. So it is 24. Now as usual, closing time of A is what? 22. That is the in time for remaining job. That is C. 22. So 22 plus 5. 22 plus 5, 27. You can see here, this is C value. 22 plus machine 1 time is 5, 27. So again here also, machine 2 has to wait 3 hours, because machine 1 will complete work after 27 only, 27 only. So 3 hours it has to wait. That is the reason. So idle time for machine 2 for this job C is 3 hours. So it has to start from 27 only. So 27 plus 1, 28. Okay. Therefore, total elapsed time equal to what? 28. Now we have to find out the idle time. Idle time for machine 1, that is M1, equal to how much? This total elapsed time and last closing time for overall job, that is 27. This is total elapsed time and this is the closing time of overall job, 27. So 28 minus 27, that is 1. Idle time for machine 2. You can see here, total time is also 28, total elapsed time also 28. So 28 minus 28 plus idle time is how much? 3 plus 1 plus 1 plus 3. So 3 plus 1 plus 1 plus 3, that is 8. So idle time for machine 1, if we take the data in hours, it is 1 hour. Idle time for machine 2, 8 hours. Total elapsed time is 28 hours. So this is how we are solving the entire problem using Johnson algorithm to find out the minimum elapsed time. So it is very simple, very interesting. So in the next video I'll take one more example on in jobs on two machines only, because with one example you may not understand it properly, or if you understand it very nice, no issues. So I'll take some two problems on the same concept. Okay, so until that you just practice this question. Okay, so thank you all.